In today's lecture, we are going to learn how to create surface-based spherical volume lattices. So to create surface-based spherical volume lattices, we need two major important geometrical parameters. They are we need spherical volume lattice, and second one is surface-based unit cells. So here we have spherical coordinate system, and by using this spherical coordinate system, we have generated the entire space volume. Suppose our home is there, suppose our room is there, so it is created by like a spherical coordinate system. So within this room, so we are going to place within the spherical room, we are going to place our unit cells. Suppose they are the surface based unit cells. In nTopology software, there are some by default surface based unit cells, so we are going to use them today. Okay, so our topic is generating surface based spherical volume lattices using surface based unit cells. They can be gyroid or split or primitive. So let's see. So for that, before that, we can give the name of the file as surface based spherical volume lattices, and our description regarding this is the generation of surface based spherical volume lattices. Okay, and our section name is surface based spherical volume lattices. Okay, so let's go to create the our spherical volume system. So for that, either we can find here spherical volume lattice, or 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 we can go to the lattice tab, and from here lattices we can select the spherical volume lattice. Okay, and here two more volume lattices are there, for like rectangular volume lattice and cylindrical volume lattices. So in rectangular volume lattices, uh, we consider the Cartesian coordinate system. In cylindrical volume lattice, we have considered cylindrical coordinate system. In spherical volume lattice, we have considered spherical coordinate system. Okay, in today's lecture, we are going to choose spherical volume lattice. Okay, let's select this. What do we observe here? Here, within spherical volume lattice, we need to define. There are some geometrical parameters, input parameters. They are, we need to specify what volume we are going to select, what volume part we are going to create within the given spherical volume lattice, that we need to specify, and that we need to specify, and that we need to specify. Next, the unit cell. What type of unit cell we are going to use? In our today's topic, we are going to generate surface-based unit cells that we are going to select, and we need to define the unit cell, like cell radius of unit cell, latitude count of unit cells, and the longitude count of unit cell within the spherical volume lattice. And the major important parameter, that is unit cell parameter. That is, if it is surface-based, then the thickness, mid surface thickness, offset, something else. If it is strut based, then we need to define the thickness of the strut, like diameter. So first, let's give one by one what is the volume of our lattice. So in today's lecture, we are going to create the spherical volume lattice, so we can select spherical volume only. If somebody wants to select cylindrical, they can select. If somebody wants to use cube, they can select cube. It is up to them. If somebody wants to select cone, they can select cone. They have to jump. It's like it is a variable of volume. It is up to anyone. It can be any complex shape. So let's go and select the volume. For that, one can type here as a sphere, or one can go to directly create and go to primitive tab and select. Yeah, as I said, there are a number of 3D volumes. So in our today's lecture, we can select the sphere. From here also, I can select the sphere, or I can directly type here like a sphere. Okay, let's select this. So what do we observe here? So there is a, to create the sphere, we need to specify the point, origin point, center point, and then we need to give the radius of the given sphere. So by default, the nTopology software has a 5 mm radius. So let's go with that. So let's minimize this, and then we need to define the unit cells. So one can double click here, and one can get the different types of unit cells. So in our today's lecture, we want a TPMS unit cell. So we can select either from here, or we can go to lattice tab and go to the unit cell tab, and then from here we can select. Either we can select this two way, or we can directly type here, like suppose TPMS unit cell with offset, like this three ways we can select. So let's go and select the TPMS unit cell with offset. We have selected. Here what do we observe? There are two geometrical parameters. One is unit cell, and one is orientation. So as we are using like symmetric spherical shape, so there is no effect, there is no much effect of orientation, as I said in previous lectures as well. So let's select the unit cell type. Okay, in our today, what do we observe here? There are total 6 unit cells of surface base. So we can select either any one of them. In our today's lecture, let's select, for time being, we can select the gyroid one. So this is our gyroid one with the offset type, and let's select this. What do we observe? This is highlighted, and let's place our TPMS unit cell here. Yeah, we have placed it. Now the size of the unit cell exactly fitted with the diameter of our sphere, it means the size of the unit cell is also like 10 mm over, because the radius of the sphere is 5 mm, then its diameter is like 10 mm, then the 10 mm size of the unit cell by given 10 10 10. Okay, let's go with that. Now the major important parameters, they are like cell radius, latitude count and longitude count, so keep them as it is. And let's the most important parameter, that is mid surface offset, then only we can able to fit or fill this TPMS unit cell, JRAD unit cell within the sphere. So let's give the 0.25 mm as a mid surface offset, and let's see what is going to happen. Yeah, so now our gyride unit cell is filled within the like our sphere. Now what do we observe? It is like almost solid type, but still it has a very beautiful shape, and it is perfectly fitted within the unit cell. Now we can tune these geometry parameters. Suppose if we give 0.1 as a 0.1 mm, then let's see what is going to happen. Okay, see how beautiful it is. Now we can also see its cross section view. If we want to see the cross section view, if we want to see the cross section view, we can see it. See how beautiful it is, isn't it? This is how we can see the cross-section view of these structures. Okay, now we can give the latitude longitude count as a 9. Let's see what is going to happen. 9 longitude came na 1 2 3 4 5 6 7 8 9. This is our cross-section view. So if somebody wants to give only 5, they can give 5. So this is how one can tune these parameter as per their requirement. And let's minimize this. And total here we have 8 na 1 2 3 4 5 6 7 8, we can say. Suppose if I give the 5, then what is going to happen? Let's see. So total 1 2 3 4 5. Yeah, this is how one can create and tune the rest of the parameters. Even now we have selected the gyroid itself. If somebody wants to select other surface based unit cell, then in that case they can play. So let somebody want like squat unit cell, then let's see what is going to happen. See, this is our squat unit cell. We can further reduce this 5 mm, 0.05 mm. Yeah, let's see how exactly it is created. See how beautiful they are. So if somebody wants other units, diamond units, it's a beautiful structure. I can say, yeah, as I said, this is a beautiful one, isn't it? Yes, beautiful. See? So yeah, thank you for this. In our today's lecture, we have learned how to create surface-based spherical volume lattices. So for that, we have selected the spherical volume lattice, and we define our volume as a sphere, and we have given the different types of surface-based unit cells, gyroid, diamond, and other unit cell split, and we tune their respective geometrical parameters. We have tuned respective, and we have given the unit cell parameters such as 0.5, like 0.5 mm. So that's it for today. So let's meet on next lecture. Thank you.